So hello students, welcome once again. I expect that you people must be solving these questions. Okay, so we are already done with few topics, including the previous one we did like straight line, circle, indefinite integration. Then we did definite integration, quadratic. Now the next one is our binomial theorem. Okay, so before I start here with the solution, I will request you all to go through the questions first and try to attempt them to the best of your capacity. Okay, because see, if you can solve those questions without any help, that will boost your confidence to the level that will help you in solving the advanced examination for sure. Okay, on the other side, if you need help, it will be better only when you have thought all the aspects which you know related to that question. Okay, so more you think, more you will learn, and better you will be prepared for your advanced paper. So that's my suggestion. So let's start. See, the first question here, see the type of questions which I have selected here is to cover the all possible type of questions like multinomial and those there are so many concepts which they normally don't ask in JEE mains. Okay, otherwise we have already done with JEE mains type of question, and if they repeat that type of question again, so I don't think you people will face any problem in solving those type of question if they repeat it similar question or similar concept questions in advance. Okay, so let's start. So the first question is 1 plus px plus x square raised to the power n is of course the highest degree term will be x raised power 2n, so it's written in the polynomial form. N is a natural number, p is a real number. The remainder obtained when a1 plus 5a2 plus 9a3 plus 13a4 dot 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 8 and n minus 3 a2n is divided by p plus 2. Now what do you people think? What shall we do here? Okay, see, as I always say, to solve any series, the first step should be to write the general term. Okay, so here I will say, since they have given this term here, so here I will say, or we may go for this 1, 5, 9, 13, that's an AP, simple AP. Okay, so 1, 5, 9, 13 and so on, that's an AP, it's general term. So rth term or AR will be what? So 1 plus r minus 1 into 4, and that's nothing but 4r minus 3, isn't that? So now start with 1, put r is equal to 1, you get 1, put r is equal to 2, you get 5 and so on. So therefore AR is 4r minus 3 4. So if I write it for the series general term, rth term for the series, so I am representing it as TR. Okay, why? Because they have already used the A1, A2, A3 as the coefficient of the terms in RHS. Okay, so if I write it general term in terms of coefficient etc., so it will be AR and then that's the coefficient x raised to the power r. What do we need? We need summation. So what we need is we need summation of TR. Okay, and then of course the coefficient summation, so we'll be substituting x by 1 in that case, so let's don't consider it right now. So TR when r goes from 1 to 2n, so this is nothing but summation of 4r minus 3 AR, r goes from 1 to 2n. Okay, now what? So now I can use the properties of summation here. What does it tell us? It tells us that we can write 4 times summation r into AR, r goes from 1 to 2n, minus 3 times summation AR, r goes from 1 to 2n. Fine enough. Now the second term here, this one is nothing but sum of all the coefficients in RHS. Okay, so now if I come back here and sum of, see what is it, summation AR is A1 plus A2 plus A3, so what we need is sum of all the coefficient from here to here. Okay, and we know in any polynomial expansion, if we have to get sum of all the coefficient, the simplest method is replace the variable of that polynomial by 1 in both the sides. So if I do it here, I am just erasing it. So if I do it here, so what will I say? Okay, put x is equal to 1 on both the sides. Never forget this. Whenever we need sum of all coefficients in any polynomial expansion, that's the simplest method to get all the coefficient, their sum of course. So put x is equal to 1, what we get is p plus 2 raised to the power n which is 1 plus a1 plus a2 and so on and so on. So summation of r goes from 1 to 10, 1 to 2n will be p plus 2 raised to the power n minus 1 if I am not wrong, isn't that? So put x is equal to 1, so it's p, 1 plus 1 is 2, 2, yeah, p plus 2 is 1. So that's the thing which you get for this term. So this is minus 3 times p plus 2 raised to the power n minus 1. This one is this. Now what about this? So this is summation of r into ar. How will we get it? See, again we will go back to the series, and if I say differentiate both the sides with respect to x. So differentiating with respect to, now why am I doing it? Because see, when in RHS you differentiate the terms, what will you get? You will get these powers as product, and that's what we need, because derivative of ar into x raised to the power r will give us r into ar, x raised to the power r minus 1. Okay, so if I differentiate it, what will we get? We will get in LHS 1 n times 1 plus px plus x square raised to the power n minus 1 into chain rule. So derivative of this term, the base here is p plus 2x, isn't that? Now in RHS when you differentiate, you get a1 plus 2a2 x plus 3a3 x square plus 4a4 x raised to power 3 and so on and so on. Now replace x by 1 bachon. So put x is equal to 1 here. So if we put x is equal to 1 here, what do we get again? See, this is n into x is 1, so p plus 2 raised to the power n minus 1, and this is again p plus 2, so it's n, and this is nothing but summation of r goes from 1 to n. I believe all of you will agree to that. So now putting this value here, we get 4n into p plus 2 raised to the power n minus 3 times p plus 2 raised to the power n plus 3 here. Okay, so if I take p plus 2 raised to the power n common, it's 4n minus 3 plus 3. So now see, we have to divide the entire. Now the question is, what is the remainder when you divide this entire series by p plus 2? Okay, so isn't this entire term a multiple of p plus 2? I think all of you agree, bachcho? It's a multiple of p plus 2, because 4n minus 3 in any case has to be an integer, okay, and p plus 2 raised to power n, so it's a multiple of p plus 2. So what are we left? So of course the remainder left is this here. So remainder is 3, so that's the answer. So the purpose of this question is how to evaluate such type of series when it's not a binomial coefficient here. Okay, AR is not a binomial coefficient in this case, so how to evaluate was the question, okay, basically. So that was your first question. Now moving to the next question. Now this question is based directly on multinomial. It's a direct question based on multinomial, but we should be ready to get or to solve such type of question. Okay, of course I told this, I said this for mains also, because they are asking lengthy question there also, and they may ask it here also. So in any such expansion, let's say x plus y plus z plus w raised to the power 10. Okay, the general term. So general term is, what is it? So x raised to the power maybe a into y raised to the power b into z raised to the power c, w raised to the power d into 10 factorial over a factorial into b factorial into c factorial into d factorial, and then where the most important part is, of course, the most important means the very crucial part is that the sum of all these power has to be 10. This power, the largest possible index. Okay, so that's it. The same thing we'll be using here. So if I write its general term ABC, so general term is ABC, ABD, ACD, BCD. Okay, ABC, let's say this for alpha into ABD raised to the power beta into BCD raised to the power gamma, and then it is ACD raised to the power delta over alpha factorial, beta factorial, gamma factorial, delta factorial into 10 factorial, where alpha plus beta plus gamma plus delta is how much? Is 10. Okay, now collect the terms, bachcho. Okay, so power of a raised to the power alpha plus beta plus delta, then b raised to the power alpha plus beta plus gamma, then c raised to the power alpha plus gamma plus delta, d raised to the power beta plus gamma plus delta. Okay, so these are the terms. Upon denominator, of course, this will remain same, into 10 factorial is same, and this remains same as it is. Okay, now compare it with the terms, with the power which we need here. Okay, so here we can write that alpha plus beta, this one is equal to, so I am writing it here only, this is equal to 8, and then it's 4, 9, 9. This is 4, this is 9, this is 9. Okay, now see, getting values is really very simple here, because alpha, beta, delta is 8, so beta is rather gamma is 2, and this will tell us alpha, beta, gamma, delta is 6, then beta is 1, alpha 1. That's it. So now just put the values here. We need, I think, the coefficient only, the coefficient. So the coefficient will be 10 factorial. So let me use just a minute. Yeah, the coefficient will be 10 factorial over 2, 6. So 2 factorial into 6 factorial. So that's it. Okay, we need to evaluate, bachcho. Okay, so 10 factorial 6, so 10, 9, 8, 7 by 2. So 2, 4, 630 into 4. So 2, 4, 630, 2520. Yeah, that's it. So that should be the answer, bachcho. Okay, so that was a question based on multinomial here again. Moving to the next question. So if this is equal to that, okay, then a1 plus 2a2 plus dot 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 nan will be how much? Now how to get it is the question. Okay, so similar but a different pattern. Okay, see, every time we have taken like 2 questions here. The first one, okay, that has a different pattern, different way to solve it, different approach. This might have different approach here. So what we need here is the value for a1, 2a2, 3a3, and so on and so on, and a and c. The value, see, of course, the method is going to be the same. Method is going to be the same. Why? Because as I said, when you need an integer multiplied with the coefficient, we go for differentiation. So if we differentiate both the side with respect to x, what will we get? So the only thing is we need to take care that what do we get here in this case. Okay, and then we will replace x by 1 here, isn't that? So let's do it. So see, when we differentiate in RHS, we are going to get 2a2 plus 3a3 plus nan. So when will we get it? After differentiating and substituting x by 1. Differentiating and substitute, put x is equal to 1. Okay, that's what we'll get. Now the entire focus is in LHS here. So when we differentiate it, of course there are n factors. Product rule says that we will be differentiating only one term at a time. So we will have n terms. Every time we will have the combination of like x plus 1, x plus 2 till x plus n minus 1. Then I will, let's say I differentiate the first term keeping the rest remaining terms intact. Then similarly so on and so on. Okay, that's the derivative. Now we need its value after x is equal to 1. So so it's like 2 into 3 into dot 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 n minus 1 plus 3 into 4 into dot 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 n plus 1, rather n here. Okay, similarly maybe 1 into 3 into 4 into n plus 1, and so on and so on. Okay, now if I see in everyone, we multiply and divide by n plus 1 here. This one term is missing in every term. 2 here. Wait. Sorry, I repeated it. Okay. Just a minute. Yeah, I repeated this. So maybe it's 1 into 2 into 4. So multiply and divide by 3. So every time when you get it, so you get n plus 1 factorial in the numerator and 1 by 1 plus 1 by 2 plus 1 by 3 and so on 1 by n plus 1. That's it. Okay, so that should be the answer. That is the answer here. Okay, wait, wait. There are 1 by 1 nahi. See how many terms we have? We have n terms. Okay, yeah, that should be the answer. So I just committed a mistake here. It shouldn't be 1 here. Why? Because see, you can't have from 1 to n plus 1 n plus 1 terms. Okay, because there are n terms as a factor. So when you differentiate one at a time, you will get n terms only as sum. Okay, so it has to start with 1 by 2 only, bachcho. We need to take care of it. Okay, so n plus 1 factorial into this, so that should be the answer. That should be the answer for sure. That won't be the answer. Okay, so that's it. So now moving to the fourth question. See, that's a simple one though. Because why? Because see, it's a binomial expansion in any case, and we know that sum of all even coefficients is equal to half times sum of all the coefficients, and sum of all odd coefficient is also again equal to sum of all even coefficient, and again it is half times that. And then we know from here that these might also be equal, isn't that? How? Because the middle term will be 2ncn, isn't that? Now from here till 2n you have n terms, and from 0 to n minus 1 you have n terms. So a term before it 2n cn minus 1 and a term after it cn plus 1, they will have same binomial coefficient. Okay, so 2n cn minus 1 and 2n cn plus 1. Okay, of course they have same binomial coefficient, same value. So a n minus weight an plus 1 a naught is 2n c naught, then 2n c1, so an plus a2 will be 2n c2, so an plus 1 will be that. They are not equal. This is an, no? Right, so this should be the case. These two must be the answer. This is for sure simple, and this should be the case. These two, since this is equal, that can't be true, and this is not true. Okay, so that was a simple question. I don't know why I selected it actually. I might have thought something else while selecting it. Now coming to this one. Now this is a series. R goes from 0 to n minus 1 raised to the power r. So you have NCR upon r plus 3cr. So my suggestion in this case is just to in the beginning itself I will first try to open both the binomial terms, okay, binomial coefficient terms in numerator and denominator. So you get r plus 3 factorial into r factorial into 3 factorial. That's gone, that's gone, that's gone. Okay, okay, 3 factorial is a constant. Okay, we'll take it out. R goes from 0 to n minus 1 raised to the power r into n factorial upon n minus r factorial into r plus 3 factorial. Okay, now we know how to balance it. We can't disturb this term. This is a variable, but this is a constant. You can disturb n factorial. Disturbing means you can bring it down, like you can write it in terms of further n into n minus 1 factorial, or n into n minus 1 into n minus 2 factorial, or you can go upstairs. Upstairs means like you can multiply and divide by n plus 1, and then you can rewrite it as n plus 1 factorial upon n plus 1 similarly. But since we have r plus 3 factorial in numerator, we need to have n plus 3 factorial, then only their difference will be this. So we need n plus 3 factorial. That means we need to multiply by n plus 1, n plus 2, n plus 3. So hence we will be dividing it outside, of course that's a constant, by this. Okay, bachon. So now the situation is, the series is this into n plus 1, n plus 2, n plus 3, and then summation where r goes from 0 to n minus 1 raised to the power r n plus 3 c r plus 3. All of you agree, isn't that, bachcho? Now see, to match this and this, what will I say? Plus 3, and I will put minus sign here, isn't that? Minus 1 whole cube, multiply or divide. Okay, so it's minus 1. Now it is nothing, so if you open it, so minus 3 factorial upon n plus 1 into n plus 2 into n plus 3. If you open it, bachon, the first term is C3. It goes till what? It goes till n plus 3. So till the last binomial coefficient, it is the series has the last term, but it doesn't start with the first binomial coefficient, which is n plus 3 C naught. And we know in such a situation the sum of all the binomial coefficient is 0. Okay, isn't that? So in general, I think you all must be knowing it, that if I write minus 1 raised to the power k n c k goes from 0 to n, this is 0. That's the situation here. Okay, the only thing is the terms are missing. Okay, so if I write all the terms here, so it will be n plus 3 c naught minus n plus 3 c1 plus n plus 3 c2 and then so on and so on till okay, minus n plus 3 c3. Let me start with the plus n plus 3 c4 till the last term minus 1 raised to the power n plus 3 n plus 3 c n plus 3, and this entire thing is 0, isn't that? Okay, so that means what we need here is this value, bacho. Okay, so this will go on the other side, so the value of this is actually this term with negative sign. Okay, so with what shall I multiply here? So I will be multiplying minus 3 factorial over n plus 1, n plus 2, n plus 3 by what? So again, be very careful, minus, we start with this term, and this entire thing is 0, so you will take it to the other side by changing the sign. So it's minus 1 plus n plus 3 minus n plus 3 c2. So n plus 3 into n plus 2 by 2. Let's simplify. So minus 3 factorial over n plus 2, 1, 2, 3. So we need to simplify it. Of course we can. We will minus n square minus 5n plus minus 3n. Okay, minus 6 plus 6 is gone, minus 2. Okay, fine, good. So this is minus gone, and that's it. N square plus 3n plus 2 is nothing, so that's what we got. So 3 factorial upon n plus, you just compare it. So a is 3, b is 1, c is 3 by 5, so it's 7 by 5. That's it. Okay, so the answer should be 7 by 5 if I didn't commit any mistake. I don't think I committed any mistake here, though you can check it out. Okay, so that was the method to solve any such series. So that was one question. Now moving to this question, this might be a common, but since I again found it to be a different type of question, okay, that's why, but I have already seen this question several times before also, so I will say it's in that case it's a known question, no doubt about it. But still, so summation RC, I will just distribute the summation over this series. Okay, so summation R goes from 0 to n minus 1 raised to the power r into n c r into 1 by 3 raised to the power r, plus summation R goes from 0 to n minus 1 raised to the power r into n c r into 5 by 9 raised to the power r, isn't that? Plus summation R goes from 0 to n minus 1 raised to the power r into NCR into 19 by 27 raised to the power r. I believe all of you will agree with me. Now these are direct simple binomial expansion. The first one is 1 minus 1 by 3 raised to the power n. Second one is 1 minus 5 by 9 raised to the power n. Then 1 minus 19 by 27 raised to the power n, and so on and so on. Let's simplify. 2 by 3 raised to the power n, 9, okay, 4 by 9 raised to the power n, so that means 2 by 3 raised to the power 2n, and then 8 by, yeah, we got it, 2 by 3 raised to the power 3n, and so on and so on. So how many terms it has? Up to 10 terms, up to 10 terms. So you have a 10 terms GP whose first term is 2 by 3 raised to the power n. Common ratio is also 2 by 3 raised to the power n raised to the power 10 minus 1 upon 2 by 3 minus 1 here, and that's it. Okay, simplify it and we get the answer whatever it is. So now I'm moving to the next question. Next one is the value of this expression. Okay, so first I think you all would have understood, though there's some the notation problem here. So I goes is greater than equal to 0, less than j, less than equal to n, minus 1 raised to the power I plus j minus 1 into nci into ncj. Now you might be thinking why I didn't write minus 1 here. I will take it out here. We will take it out. Okay, so now see, so if I write it, I will be writing it as minus times I goes from 0 to less than j less than equal to n, and then minus 1 raised to the power I into nci into minus 1 raised to the power j ncj. I don't think anyone will mind me writing this thing, isn't that, bacho? Now what? See, now for this one I will prefer to use the matrix method. Now what is it? So I will try to form a matrix here. Okay, so first one is for I. So minus 1 raised to the power I nci, I goes from 0 because I starts from 0. Okay, and I am taking it till n. So first one is of course 1, which is nc naught. Second one is minus nc1, then it's nc2 minus nc3 and so on minus 1 raised to the power n ncn. Now similarly along the column I will write for j. Again j also goes till n. I am assuming it to be starting from 0. Okay, so again it's minus 1 raised to the power j into ncj. So the first one is again nc naught, and again it is minus nc1, nc2 minus nc3 and so on minus 1 raised to the power ncn. Okay, so now let us try to complete this matrix. Okay, so something like this. Now in the first one it is like nc naught into nc naught. The second one is minus nc naught into nc1 plus nc naught into nc2 minus nc naught into nc3 and so on. So whatever we have nc naught into ncn minus 1 raised to power, and similarly the second one, the second row. So it will be minus nc1 into nc naught plus nc1 whole square minus nc1 into nc2 plus nc1 into nc3 and so on. So let me write one two more. So nc2 into nc naught minus nc2 into nc1 nc2 whole square and so on. Okay? Now if you mark along the diagonal, it's a square matrix. Okay, so you have a diagonal. The diagonal elements are nc naught whole square, nc1 whole square, nc2 whole square. Now diagonal elements in a square matrix we get when I is same as j. So we get diagonal when I is equal to j. Okay, we need those elements in the product. See, I am trying to figure out that the components of these series, this terms, where will you get these terms in the matrix? Okay, so these terms you get when I is less than j. Okay, and as I said, this represents I and this represents j. So I will be less than j only when the elements are below the diagonal. Am I clear, bacho? Or am I correct? Isn't that? And of course, see, and I will be greater than j. Let's say this is, see, j is 0 and I is 2 here, j is 1 and I is 2 here. Okay, so I is greater than j when it is, so I is greater than j above the diagonal elements. But coincidentally, and this is where actually this series work, bacho, coincidentally if the elements, it's a symmetric matrix, isn't that? See, this and this element is equal, this and this element is equal, this one and this one is equal, minus nc2 plus, so it's a symmetric matrix. Okay, now see, this is when, see, if you, once you get a symmetric matrix in such type of series, you can easily solve it. Now, why? First, I will write sum of all the elements in the matrix. How will you get it? So you'll get it when you actually multiply this thing, whatever, I mean minus 1 raised power n, whatever, into the same thing. Yes or no, bacho? So when you multiply them, you will get all possible terms by nc naught whole square, the first one, nc naught into minus nc1, so nc naught into minus nc1, and minus nc1 into nc naught, minus nc1 into n. So you will get all possible elements, the entries of this matrix here. Okay, now but we know some this is 0 and this is 0, so this is actually 0. What does that mean? Sum of all the elements in the matrix is 0, first thing. Now can we find the sum of all the elements along the diagonal? Now that's simple. Along the diagonal, so what is it? So this is nothing but nc naught square, nc1 square. I believe all of you must be knowing it. If not, then remember it. nc1 whole square. The value for this series is 2ncn. The value for this series is 2ncn, bacho. Okay, so that's it. Now what? So therefore, okay, let me write it here. Therefore, see, this series, if I call it as S is equal to sum of all elements minus sum of diagonal elements divided by 2. Why? Because as I said, the elements which you have above and which you have below the diagonal are same, exactly same. Though in this question we need those sum of all the elements which lie below the diagonal, but since they are same, so if this is P, so P plus P, 2P plus diagonal elements give you sum of all possible elements in the matrix. So we have the answer. Okay, so therefore, so let me write it here. Therefore, S is equal to 0 minus 2n Cn by 2. So it's minus 2n factorial by n factorial into n. See, why am I doing it? Because when I got this question as a doubt, I solved it. The answer was in terms of something else. So what was that? So if you further simplify it, I'm not sure about minus. It should be, okay, wait. You already had a minus sign here. Okay, so it will actually be positive. Okay, so it will get positive because S is minus times this thing, fine. So it's positive, so I will write 2n factorial as 2n into 2n minus factorial. 1, 2 and 1, 2 will get cancelled, so it will be 2n minus 1 factorial upon n factorial into n minus 1 factorial, so which is nothing but 2n minus 1 Cn minus 1 or 2n minus 1 Cn, that's it. Okay, so that was one question which I picked up so as to discuss the matrix method to solve such series, bachon. Okay, so that was the purpose here. Now moving to the next question. Now that's a summation question, basically series question. But okay, see, since when I was selecting question, I got this question as a doubt, so I just included it here. Maybe I may forget later. I may forget it when will be solving the questions of series. So that's why I included it here. See, the general thing, I mean, when a series, I can't match it with any standard form. Standard form means like GP, of course, no, it won't be an AP or GP series directly. It can't be in either in JEE Mains or Advanced. But AGP, of course not. Method of difference, of course, that's not a series. Summation rule, we can't apply. What are we left with? So that's how I always start thinking. So we are left with the method which is the most important method in solving series, and that is breaking the general term as the difference of two terms, preferably the difference of two consecutive terms. Okay, so that's how I started thinking on it. And see, without thinking anything, I just opened the bracket because I couldn't find anything direct here. So I just opened the bracket. Then I realized, I think most of you would have got this question. Okay, then I realized that you have this term here, R4 R square plus 1. So I just wrote it in two form. r4 plus r square plus 1. And what are we left with? We are left with r cube plus r square, and that gave the idea. How? Because see, when you divide it by the denominator, you are left with this thing, and when you divide this by denominator, okay, you are left with r here. That's it. So what happened actually is, you could rewrite the series as summation of 1 upon r into r plus 1, which we can directly write as the difference of two terms. So that's separate series. When r goes from, preferably, of course it's from 1 to infinity, it can't be from 0 because we have r in the denominator. Similarly, when r goes from 1 to infinity, it is r. So I'm dividing and multiplying by 2, and I will rewrite it as adding r square and subtracting r square. So that might be something new for maybe few of you at least. So this we can directly write, if you all agree. I don't think anyone will disagree with me. I'm writing it directly. You can use partial fraction. Okay, and here it is half times summation. So this is C, a square, it's r square plus 1 whole square, b square, so it's r square plus r plus 1, and r square minus r plus 1, a plus b into a minus b, okay. And then this is 2r. Now 2r is nothing but difference of these two, okay. So hence we can write the entire series as difference of two term series in two different forms. One is this one, which you can solve easily, and another one is this minus this. So r square minus r plus 1, rather plus r plus 1 minus r square minus r plus 1 whole divided by this. So this is nothing but half times summation, and summation 1 upon r square minus r plus 1 and minus 1 upon r square plus r plus 1, and that's it. Okay, so now we know what to do. Just go on putting the values from r, and of course since it is infinity, the last term left is of no use. Why? Because it will go to 0 as r goes to infinity. Okay, so the terms which you are left with initially are the terms which are going to contribute in the answer. So do it and you will get the answer. So that's it. Now moving to the 9th question, the sum of this series. So in this question the series is summation r goes from 1 to 3n minus 1 minus 1 raised to the power r into r by 3ncr, and I took minus sign outside again. Okay, now see, in this case, if you add these two, the lower limit of the variable r and the upper limit of variable r, you get it as 3n, which is constant. I mean this equal to this superscript of the binomial coefficient. Okay, so I'll be using here Bahubali property. So what does it say? Bahubali property, actually that's a property which we come across, which we read, study in definite integration. And what is it? So a to b f of x dx is equal to a to b f of a plus b minus x with respect to x. That's Bahubali property. So what it says basically, that if you replace the variable of integral by the sum of the limit minus x, the value doesn't change. The same thing I'm going to use here. The variable of summation is r, and if I replace r in the summation by sum of upper and lower limit minus r, the value remains same. So therefore s is equal to minus times summation r goes from 1 to 3n minus 1 minus 1 raised to the power 3n minus r. Isn't that? So it's 3r replacing, because sum of lower and upper limit is 3n. So I'm replacing r by 3n minus r, and then it is 3n minus r upon 3n minus r, which is actually, this is why we are able to use this property, or this property will actually be helpful in solving question. Why? Because again you'll be using the property of binomial coefficient, which says ncp is equal to ncn minus p. Okay, so this is same as this. Now as we do in definite integration also, the same thing I'm going to do here, and that is we add the series, okay, the given series and the one we obtained after applying this Bahubali property. So adding 1 and 2, so we get 2s. See, everything is same. I mean denominator is same, minus 1 is there. Acha, one more thing, I think n is even natural number. Yeah, that's what we are given. N is an even natural number. So I can write it as minus r, isn't that? Okay, because whether 3n minus r is even or odd simply depends on r. Okay, and minus r, so it's whether and not minus 1 raised to power minus r or minus 1 raised to power r is same, so I will write it as plus r. Okay, so now adding them you get 2s is equal to minus is common, minus 1 raised to the power r is common, r plus 3n minus r upon 3n cr, and this gets cancelled, so this is equal to 3n minus summation minus 1 raised to the power r upon 3n cr. Okay, so therefore s is equal to minus 3n by 2 summation minus 1 raised to the power r upon 3n cr. Now the challenge is to get minus 1 raised to the power r 3n cr. Okay, so that's one way of getting s. So now see, one more way we can try is minus times r goes from what? 1, right, to 3n minus 1 minus 1 raised to the power r, and r. Okay, so if I write 3n cr as 3n factorial into r factorial into 3n minus r factorial. Okay, so now I may go with trying this method where I will rewrite it as r plus 1 minus 1 into r factorial 3n minus r factorial upon 3n factorial, breaking it into two different form. Okay, so minus summation r goes from 1 to 3n minus 1, and then this is 3 r plus 1 factorial. Okay, 3n minus r factorial, multiply and divide by 3n plus 1, isn't that? So it will be here 3n plus 1 outside here. So that's balanced, because now I'll be writing it as, so denominator is of course 3n plus 1 factorial. Okay, so I'm writing it as 3n plus 1 cr plus 1. Okay, let's see how does it help. And then okay, minus is plus, that's 3n factorial of course, है ना, plus r factorial, so plus r goes from 1 to 3n minus 1. I missed minus 1 raised to power r also, so this has to be here also, this has to be there also, minus 1 raised to power r upon 3n cr. Okay, I know this value. Okay, so s is equal to minus times 3n plus 1 summation minus 1 raised to the power r upon 3n plus 1 cr plus 1 बच्चों. Now what about this? We know this value. So this value is nothing. So summation minus 1 raised to the power r upon 3n cr is equal to minus 2s by 3n. Okay. So it's minus 2s by 3n. So minus 2s by 3n, take it this side. So it will be s common by 3n, and it will be 3n plus 2 is equal to minus 3 times n plus 1 minus times summation minus 1 raised to the power r. Okay, so I will take this minus sign inside, r plus 1 upon 3n plus 1 cr plus 1. Okay. Now the point is how to get it, isn't that? Do I have a slide? Wait, no. So shall I go back and then maybe, yeah, this I may erase. So now the thing is, we have this situation where it is 3n plus 2 s upon 3n is equal to minus times 3n plus 1 summation minus 1 raised to the power r plus 1 upon 3n plus 1 cr plus 1. Okay. See, that means we are quite close because 3n plus 2 here, 3n plus 2 here. So, and 3n plus 1 here. So that means that should be the answer. So we should be able to get it. I'm not so sure what I did after it. Actually, I got this question few days back only, and I got the answer. I think C or D. Of course, C or D is the answer. I think C is the answer. What I thought after that. See, that happens. Okay. If I open it, R goes from 1 to 3n minus 1. Okay. When R is 1, it's plus, okay, 1 upon 3n plus 1 C2 series is given for 3n. We'll get the terms for 3n plus 1. Wait. Just a minute, let me think. What is that? I just missed what I did. If R starts from 0, the first term will be okay. Yeah. Wait. See, 3n is even. Okay. So it will be 3n minus 1 plus 1. Okay. It will be, just a minute, bachcho. Right, wait. Let me write the two last terms. Okay, as I wrote the first two terms for R1 and 2. For R is equal to 3n minus 2. It will be plus 1 because 3n R is 3n minus 2 plus 1 3n minus 1. It will be minus. Okay, it's a minus 1 upon 3n plus 1 C 3n. Okay, when R is 3n minus 2, R is 3n minus 2, it's minus 1, no? It's odd. Plus 1 upon 3n plus 1 upon k. It's not going till the last term. Fine. So if I add and subtract this term, what's happening is, how many terms we have? We have even number of terms. Okay, got it. Yeah, sorry, got it. See, so I subtracted it, I need to add it. Okay, now see, what's happening here is that this and this is same, opposite sign. 3n plus 1 c1 is same as 3n plus 1 c3n. This and this, and since we have even number of terms, all will get cancelled. You will be left with only this, and this is 1 upon 3n plus 1. This and this gets cancelled. So the answer, I'm sorry, answer should be this. Oh, so finally we got it. Okay, so that's what I did. So we just expanded it. Okay, and then all the terms got cancelled. So that's it. So that's the 9th question here, and that's the 10th question. The value of this series k goes from 0. So see, if I move ahead with two different terms, of course. See, in numerator, if I am looking at here, the sum of the subscript of binomial coefficient is a constant, which is r, because the variable of this summation is k here. So it's a constant. Okay. So that means whenever that happens, we go for getting the coefficient of x raised to the power r in the expansion. The only thing is how to write that binomial or whatever it is, for which we get this as the terms of binomial coefficients. Okay. So if I go for x plus, since the difference is of 2 every time, 1 plus x raised to the power n, the general term will be nck x raised to the power k, and 1 plus x raised to the power n minus k. Okay, if I go for the coefficient of x raised to the power r, so it will be like or here nck. Okay, so it will be, if we have r here, we need n minus r, which is n minus r cr. Isn't that, bacho? But the point is, okay, we need n minus 2k here, isn't that? So 1 minus n minus 2k means I need to divide by 1 plus x raised to the power k. So that means if we consider this to be the binomial. Okay, now rewrite. So actually what I am trying to do is, if I consider this as my binomial expansion, okay, this is a, this is b, fine. So it will be ncp x raised to the power p, okay, 1 plus x raised to the power n minus 2p, right? Now, whatever coefficient we need, like if we need coefficient, the sum of all the terms with for the coefficient of x raised to the power 10. So if we have 9, we need 1 here. Okay, so n minus 2p when it is 9 to n minus 18 c1. Okay, so it will be like nc 9 and then n minus c, nck and minus n minus 18 c 10 minus 1, so c1, because n is r is 10, I mean r is a constant, so if we are looking for, so it's 10 minus 9, so that matches. So that means we will be looking for coefficient of x raised to the power n in this expansion. Now going for the second one, the denominator one is, so nck into 2kc2r 3 by 4 raised to the power n minus k into 1 by 4 raised to the power k minus r, and the variable here is k again. K goes from r to n. So r is again a constant. So r is a constant, so I can write it as k goes from r to n, nck into 2kc2r 3 by 4 raised to the power n minus k into 1 by 4 raised to the power k into 4 raised to the power r. So that's a constant. Okay, so let's take it out of the summation symbol. K goes from r to n, nck into 2kc2r, and then it is 3 by 4 raised to the power n minus k into 1 by 4 raised to the power k. Okay. Now So superscript of this binomial coefficient is changing with the difference of 2. So what can we think about here is, so let us consider, okay, let us consider a binomial expansion of the form, just a minute, 1 plus, okay, see, 2r, that's fixed. So in every term, if we look for the coefficient of x is per 2r. And I can very well write it as n minus k. Okay. Okay. So if I consider so it's 3 by 4, I have to write the binomial, okay, wait. So it's 3 by 4 plus 1 plus x whole square by 4 raised to the power n. Let's write the general term. nck 3 by 4 raised to the power n minus k हमें उधर चाहिए था. Okay, so that's why I chose to rewrite write it as this form, the reverse order, right? That's why I wrote it in the reverse form, 4 plus 3 by 4 is for n. Okay, so if I go with the general term, so nck 1 by 4 raised to the power k into 1 plus x square raised to the power k, which is 2k, into 3 by 4 raised to the power n minus k. Isn't that? So here we have to collect, so that's all the coefficients. So here in this expansion, when k goes from, that's a general term, so when k goes from r to n, we have to collect the terms of x raised to the power 2r, so terms of x raised to the power 2r. So the coefficient of x raised to the power 2r in this expansion is actually our series, bachon. So coefficient of x raised to the power 2r here will be the value of this series. So in numerator we have to look for coefficient of x raised to the power here, r here, and in denominator we have to look for coefficient of x raised to the power 2r here. Okay, so that's it. Now you should try to evaluate. Okay, so that's it. So those were the 10 questions for binomial. Now the next one will be permutation and combination. Okay, so now keep trying, keep solving the questions. Okay, as the days will get closer, I'll be giving some miscellaneous questions also in between. So because see here in our campus at Adi Bartlett, Tiruto, students are regularly now asking questions, so I'm getting good questions as doubts. Okay, so I will in between somewhere, maybe I don't know about the frequency, but as many questions as I get, depending on that, I'll be putting up the miscellaneous type videos also, maybe 8, sometimes 5 questions, 8 questions, whatever it is. Okay, so you all will enjoy it. So keep solving questions, because this momentum will help you in your advanced paper. So what I wish here is that you people should go to the advanced for your advanced paper to the examination hall by solving many different type of questions. But also keep solving as many questions as you can. Of course, the good questions, as many as you can, but from different sources. So I am also trying to provide you the question. You have other sources, so do try to solve those questions. PYQs are always good. Keep solving previous year questions also of JEE Advanced. Okay, so chaliye, we'll meet in the next video next time, bachcho.